Hi, Abid here. In today's video, I'm going to show you how to set up the Qemu KVM virtual machine and LXC system container lab on a new Ubuntu22 desktop virtual machine that is actually running on Oracle VirtualBox on a Windows 11 host machine. So after the intro, I'll get back to you. We are now ready to get started. Last week I set up and installed a new virtual machine for Ubuntu22, and I also created a template by exporting that virtual machine to an OVA file. So I'm going to use that OVA file to create a new virtual machine in Oracle VirtualBox. I'll double click on that. And the first thing we will do is set the amount of RAM for that machine. So I'm going to change that to 16 gig of RAM as follows, and click on finish to carry on. And we'll just wait for the virtual machine to be imported from the OVA file. So I'll pause the recording and resume the recording once the virtual machine has been imported from the OVA file. The virtual machine has now been imported, so we are now ready to start it. And we'll just wait for it to power up. So I'm actually now running VirtualBox 7, which brings a lot of changes to the previous version of VirtualBox host we ran a few years ago. So on the right hand side, I'm going to close these messages in relation to mouse integration and keyboard capture, and I'll wait for the VM to start up, and I'm just going to hit full screen mode and I will log in. We are now logged in. I'm going to open up a terminal session. Just going to zoom in just to make it a little bit easier to read. I'm going to navigate to my home directory just by typing cd, hitting enter. If I hit pwd, I'm in my home directory. The first thing I need to do is install Git, so that will allow me to pull down my code from the GitHub repository. So it's sudo space git, sudo space apt install git -y, put in my password, and Git has now been installed. I'm just going to take that out of full screen, and I will bring in my web browser window here. So this is my GitHub repository here, and this is what I'm going to be pulling down. That's the actual link there. So I'm just going to pull that down. So to do that, it's git space clone that's link. Then I'm going to put in the name of a directory called bin here, and it's cloned that repository to bin by cd into bin. This is the code. Now what I need to do next is to install some Python libraries. So I'm going to go ahead and install that using apt-get. So sudo apt install python 3 pip, also python 3 virtualenv. So I'll be using Python's virtual environment feature to install some libraries without affecting the rest of the system. So we'll just wait for it to download and install those. Okay, so those have been installed. What we need to do next is to install LXD, and that's installed via snap. So sudo space snap install LXD. Wait for it to download and install that. It will take a couple of minutes. LXD has now been installed. We will now configure it via LXD space init or LXD space init. For all of these options, I'm going to use the default values apart from IPv6. So I'll just go ahead and do that now. I'll also set this to a different value as well for the size of the loop device. For IPv6, I'm not going to use it, so we'll type in none. So I'll type in LXC space list, and LXC is now ready to be used. Now what I will do is I'm going to activate the Python virtual environment inside this local repository. So to do that, it's source space. So before I do that, I need to enable it as a virtual environment. So it's virtualenv space full stop for the local directory. That will create an environment within that directory to enable me to use a virtual environment. So then to enable the virtual environment is source space bin. There's a bin directory inside bin. Then activate, and I've now activated the virtual environment. So I will now install some Python modules inside this virtual environment, and those Python modules will only be available when we've activated this actual environment, and then it won't affect the rest of the host system. So the modules I will install using pip3 is Flask, which is for the front end, and it's just for development front end. psutil to get system information and display it via Python, and also toml so that we could read toml files. Okay, we will now start the front end. So I'm just going to type in Python 3 space frontend.py, and it's now started the web server on this IP address, which is the IP address of this virtual machine, and I will navigate to that from my actual Windows 11 host machine. So let me go ahead and do that now. Let's bring that web browser across. There we go. So what you can see here is we can see a host system information summary at the top. I've also started reporting on the status of the system. Currently this only reports on the temperature value here. Just a slight caveat, because this is a virtual machine, the temperature value is not available to the virtual machine. So as a workaround, I've set this value to 0, but if you was to run this tool directly on Ubuntu, which is installed directly on hardware, you would actually get an actual value here, and what you see here on the top left would reflect that. Okay, what we can do now is I'm now going to start the process of creating some instances here. So there's no instances, so you're seeing 0 here, and no instances being reported. So what I would do is, if I go into the Ubuntu virtual machine, I'm going to open up a new tab. We'll zoom in right there. Make sure we're using the virtual environment. So it's source, bin, activate. Then we've got a file inside there called toml. So if I go to that file, these are the instances defined in this toml file that the script will attempt to create. Now, this virtual machine doesn't support nested virtualization, so it will skip over these entries that are type VM, and it'll just go ahead until it finds entries for containers such as this one here, and it'll create those. And you'll see that when I start running the script as follows. So this is the process to run the script. Okay, so looking at the first value in the toml file, it detected it doesn't support virtualization, so it's going to skip that and move on to the next entry. And I'll go back to the actual web browser, and once the instances are created, you'll see it start to be reported here as well. So what I can do is bring this up again here. So we'll just let this run, and let's see if I could split that across. Okay. So it doesn't look too elegant, to be honest with you, but in my previous video I did show a terminal with this being created, and the web browser on the right hand side showed the instances once they get created. So let me see if I could maybe zoom in a bit, or sorry, zoom out a bit, just to make it a bit more easier to see what's going on there. I will stop talking at this point and speed up the rest of this segment for this video. The lab has been created. It took approximately 16 minutes 31 seconds for it to be created. On the left hand side here, you can see that it's failed to create 10 of the instances within the toml file, because these are actually VMs, and the actual Ubuntu22 virtual machine itself doesn't support nested virtualization. So that's the reason why these were not created. So I will maximize the browser window here. I will zoom in just a little bit to be more clear there. So yeah, so you can see the information in relation to those instances. In this case, these are LXC system containers. So this is at a very early stage, but you can see the name, the amount of cores allocated, the amount of RAM allocated, the date it was created, CPU usage, which is quite raw at this moment in time. So this is something I will be cleaning up in a future iteration. Same with RAM, whether it's running or not, the type, and the OS that's installed. And this is actually real time. So if I was to shut, say, this one down, Ubuntu, it'll be reflected in the actual web UI. So let me go back to Ubuntu. Let me put that there, put that on the right hand side. You can see Ubuntu there. So let me stop Ubuntu. So it's LXC space stop Ubuntu container. Let's maximize that. We'll wait for that to run. Just put that back on the left hand side. So it's actually stopped it. So let's maximize that. and you can see it's now showing us stopped there. And if I start that back up again, oops, typo there, so take out the U, try that again, go back there, we'll wait for it to start that back up again. And it's okay, it's already, yeah, it's already started it up, so it's up and running now. Okay, so thank you very much for getting to the end of this video. Please click on like if you like this video. Please feel free to comment on this video if you have any questions. Also, if you like the work I do, please feel free to support this channel by subscribing to the channel. And also, please do not forget to hit the notification bell should you wish to be notified when I upload further videos in the future. And thank you very much for your time, and I hope you have a good rest of the weekend wherever you are. Thank you.